All right, here's the homework sheet that goes with irrational zeros and Descartes rule of science. List all possible rational zeros and find all the zeros. So if I'm going to list all the possible ones, it's all the numbers that go into 24 evenly. So there are all the numbers that go into 24 evenly. I'm not going to use Descartes rule of science because I can factor this. So two numbers that multiply to 24 and add to negative 25, that's negative 1 and negative 24. Then you can take each factor equal to 0 and solve it. So I'm going to add 1 and take the square root, so it's positive and negative. Now the square root of 1 is 1. This one you add 24 and take the square root, so it's positive and negative. 24 is 4 times 6, so the square root of 4 is 2, so it's really 2 root 6. And then you have all the zeros. So in this case you have two rational zeros, that's 1 and negative 1, and two irrational, 2 root 6 and negative 2 root 6. So I only use the rational zero theorem if I have to, not because of any other reason. So I'm not going to list the possible rational zeros if I'm factoring. So like for number 2, I'm factoring. What do they have in common? An x squared, and you have 5x minus 1. What do they have in common is a negative 5, and you have negative 3, and you have 5x minus 1. So because they share the same factor, 5x minus 1, and you're left with x squared subtract 3, it's now factored. So now you can say what the zeros are. So from the first factor, you'd add 1 and then divide by 5. That's rational. For the second one, you'd add 3 and then square root. So it's plus or minus the square root of 3. So you can see 2 irrational and 1 rational. This one is not. Is it factorable? So if I take out 8, yeah, it is factorable. So I'm going to factor it out. I'm just saying that if I take out a common factor, if the factors will match. So I'm going to take out an x squared, and you get 3x plus 2. I'm going to take out a negative 8, and you get 3x plus 2. Beautiful. So they both have a 3x plus 2, and you're left with x squared subtract 8. Now from each factor, you get a 0. So from the first factor, you subtract 2 and divide by 3. The other one, you add 8 and then the square root. Now the square root of 8 is 2 root 2, plus or minus. Recognize rational and irrational, but all three are real. Number 4, again, I'm going to do this by factoring. So in order to do this factoring, I need to be able to go 2 times 4 is 8. And what two numbers multiply to 8 and add to negative 9? So it's negative 8 and negative 1. And then I'm going to factor by grouping. So I'm going to factor out a 2x squared. So I have x squared minus 4. Factor out negative 1, and you have x squared minus 4. So x squared subtract 4, 2x squared minus 1. That's what's left. So each one I'm going to make equal to 0. So I'm going to add 4, and when I take the square root, it's plus or minus 2. That's rational. For 2x squared minus 1, I'm going to add 1, and then divide by 2. Now when I take the square root, again it's going to be plus or minus the square root of 1 over root 2. I'm going to let that go for right now for this lesson. So the zeros are plus or minus 2 and plus or minus 1 root 2. Now I want you to notice that these irrational zeros are always coming in pairs. So for a polynomial, an irrational, you have positive and negative, whatever that irrational number is. A rational number doesn't have to come in pairs, but an irrational, one's positive and one's negative, always coming in pairs. All right, state the positive and negative real zeros. So Descartes rule of science. So positive, negative, 1, 2, 3. So there's 3 or 1 positive zeros. Put in a negative number. Now, if it's an odd exponent, the sign stays the same. And even, it change. Try it again, Mr. Gertson. Here we go. An odd exponent, it changes. An even exponent, it stays the same, changes, and stays the same. No sign changes, no negative zeros. Let's try it again. Here we go. The signs, plus, minus, plus, 1, 2, 2 or no, real, positive, zeros. Next, put in a negative number. So even stays the same, even stays the same, stays the same. So that means for both it's 2 or no, real, negative, zeros. There it is. All right, there we are. Turn the page. Again, press pause, do the work, and then play the video and see if we agree. 1, 2, 3, 4. 4, 2, or no. So notice the sign changes gives you the maximum number, and then you count down by 2. If you put in a negative number, you're looking at the exponent. An odd exponent changes, even stays the same, changes, stays the same, and stays the same. So there's only one sign change, so there's one negative zero. Here we have all positives. No positive zeros. No sign changes. For a negative, stays the same, changes, stays the same, changes. 1, 2, 3. So there's 3 or 1. Negative zeros. All right, 3 more questions to put it all together. Great working with me. So create a list, if I have to, which I do in some cases, then find all the real zeros. Use Descartes' rule of signs to help you out. So the first list is 1, and then 1/2, and 1/4. So there's my list. For Descartes' rule of signs, positive, negative, positive, positive, so that there are 2 or no positive zeros. Then odd exponent changes, even stays the same, changes, stays the same. So there's 1 negative 0. And because I know there's 1 negative 0, it might be that we start there or may not. So let's see. So we have 4, negative 7, 2, and 1. So I would think there's for sure 1 negative. Maybe I should start there, but this adds up to 0. So I know positive 1 works. What did I just do? 4, negative 3, silliness. So this is negative 1 and negative 1. Now notice that 4 take away 3 take away 1 adds up to 0 again. So again I'm going to use 1. Man, I gotta think through this. All right, 1. 1 times 1 is 1. All right. So what I'm left with is 4x plus 1 equal to 0. Notice I just kept going to find the zeros. I didn't factor because it was so simple to just keep going, subtract 1 and divide by 4, that if all I want to do is find the zeros, then it was positive 1 and negative 1/4, where positive 1 has a multiplicity of 2. So I could have stopped there, but then it would have been like tough factoring, taking all kinds of steps. Positive 1 obviously went into it evenly, so then what was left over was so easy to solve, equal to 0, that it was easy to find the zeros. All right, 2 left. Not factorable, at least not from not doing the rational zero theorem. So there's my list. Positive, negative, negative, positive. 2 or no. Positive zeros. Change. Stay the same. Change. So there's 1 negative. That could be real or, that could be rational or irrational. It just means it's real. It does not add up to 0, so that's not going to work. So if you try, it's negative 5 is the one that works. And I have x squared subtract 12x plus 3 equals 0. I'm going to complete the square. So we have an even number for b. A is 1. So if I take b and divide by 2 and square it, I get 36. So negative 12 divided by 2 is negative 6. And then if you square it, it's 36. So I'm going to have 36. I'm going to subtract 3 and add 36. So the left side becomes x subtract 6 squared. On the right side is 33. When I take the square root, it's plus or minus square root of 33. Add 6, and you have your answer. So what are all the zeros? So it's negative 5, 6 plus root 3, and 6 take away root 3, 33. So you see the 2, this 6 take away root 33 is a positive answer, and then a negative answer. Notice again they come in conjugate pairs. All right, number 11. Last one. Create a list. We still got to divide by 2, so the odd numbers I'm going to divide by 2. Positive, positive, negative, negative, positive. That's 1, 2, or no. Positive zeros. Here I got positive, negative, negative, positive, positive. So 1, 2, again, 2 or no. Negative zeros. So I'm going to use synthetic division. It does not add up to 1, which is 0. So I'm going to put in a different number to try it. So 3 works. Oh, not negative 3. 1/2 is the other one that works. So half of 2 is 1, half of 12 is 6, half of 8 is 4, and you can see what's left over, 2x squared plus 12 plus 8. Divide everything by 2. X squared, that's a 4. It's not factorable. I'm going to complete the square. So 6 divided by 2 is 3, and 3 squared is 9. So it'll be x squared plus 6x plus 9. Subtract 4 plus 9. So x plus 3 squared and 5, and it's pretty well done. So square root plus or minus root 5, and then subtract 3. So there you go. Those are all your zeros. So what are they again? So they're positive 3, positive 1/2. Negative 3 plus root 5, negative 3 minus root 5. These are negative, and these are positive. And that's what it said. 2 positive zeros, 2 negative zeros. 2 that are rational, 2 that are irrational. So I'm so proud of you. You got to the end of the homework sheet and practiced with me. And we're done. Mr. D Math, over now.